Hello students and welcome to the class again. Students, this video is to make you out or to take you out from the curiosity of functional groups. I know you all want to know about functional group, but yes, nomenclature of functional group is been removed from your syllabus at this year. It is this year it is removed. So, but still, for your curiosity and for your for to know things, I am just giving you some basic knowledge so that whenever you are seeing all these compounds, you will not feel hesitate to take their names. So I have tried to assemble some of the videos which will make you understand the topic which we are talking about, carbon and its friends. So let's know some more of the friends in some more details. Okay.
By now, we are well versed with what functional groups are and how they affect the properties of our hydrocarbons. Now, the next important thing in our list is to name the carbon compounds that have functional groups attached to it. Why do we need to learn this? We have already learned how hydrocarbons are named in our previous videos. We have studied the nomenclature of alkanes, alkenes, and alkynes. Maybe we just have to add the name of the functional group that is attached to it, right? No, it's not that simple. How will we write the name of the element? The functional group first or the hydrocarbon first? And what if two functional groups are attached to the hydrocarbon chain? Well, there are many factors that can influence the naming of our hydrocarbons. So how do we name them appropriately? This is where the IUPAC comes to our rescue. It's the International Union of Pure and Applied Chemistry. The body is known for setting up rules in chemistry. Laying the rules for scientific nomenclature of elements and compounds is also something they do. Let's have a look at a few points to keep in mind for understanding the nomenclature system. Similar to naming the hydrocarbons, here too, we name the compound in two parts, the prefix and the suffix. The prefix is usually decided by the parent hydrocarbon. And what is the parent hydrocarbon? Parent hydrocarbon is the principal chain of hydrocarbon that has the respective functional group attached to it. So if the hydrocarbon A is attached to the functional group B, then A becomes the parent hydrocarbon. Now what will the suffix be? Yes, the suffix has to be the name of the functional group attached to it. So for naming the compound, there are a few things that we need to remember. The first thing we look for in the compound is the chain with highest number of carbon atoms. The parent chain of hydrocarbon will be the one with maximum number of carbon atoms in series. What do we mean by this? Say we have a 10 carbon long chain with no branching. Such a chain will be our parent chain. Now what if the chain of 10 carbon atoms comes in the form of branches like this? Here can we say that the principal chain is 10 carbon long? If you keenly observe, the longest chain having carbon in a straight line or series has 8 carbon atoms. Yes, this chain has 8 and this one has 7. We consider the longer one. That is why this compound, in spite of having total 10 carbon atoms, will have the parent chain of 8 carbon atoms only. What about the remaining 2 carbon atoms? The remaining 2 carbon atoms will be considered as side chains. That is what we look for in the beginning while naming the compound. It helps us decide the prefix as it depends on the number of carbon atoms in the parent hydrocarbon. Now what should we do next? After the prefix, it's time for us to look for the suffix. Here, the suffix is decided by the functional group attached to the parent chain. Yes, the parent hydrocarbon decides the prefix and the functional group decides the suffix. Just like we had ane, ene, and ine for alkanes, alkenes, and alkynes, the endings of the functional group are added accordingly. So if we have an alkane and the functional group attached is alcohol, then we replace the E with the OL in its name. The alkane ethane will become ethanol. For the suffix, do we always take the last 2 letters of the functional group? Not necessarily. Here is a table that gives us an idea as to how the suffixes can be added for various functional groups. So we have ol for alcohol, al for aldehyde, O for ketone and oic acid for carboxylic acid. But notice the case of halides. It's slightly different. Naming the compounds with halides comes in two ways. One system is haloalkane, where the halogen is named as the prefix and the alkane name appears as the suffix. Thus, we add the prefix chloro, bromo, fluoro and iodo respectively before the parent hydrocarbon. So if we have chlorine attached to the methyl group, we say chloromethane. The other style of naming the compounds is called the alkyl halide style. In this, the alkyl name is written first, followed by the terms fluoride, chloride, bromide and iodide. So the chloromethane can also be referred to as methyl chloride. There are many other rules as well, like in the case of compounds with two or more functional groups. But we will learn about these complex compounds in our higher grades. So for now,
See students, we were talking about friends of carbon. So one of the friend, that functional group, is known as ketone, right? So we can write the general representation. See, ketone group is this. So you can make a circle over here, right? Just to tell that yes, it is a ketone group. Okay, just to remark, just to recognize properly. And this, see, I have mentioned R and here R dash, and that is what does it represent? This R, this shows the alkyl groups which may be the same or different. Alkyl group, students, which we have understood in the last video, alkyl group, if you remove one hydrogen, then these are ready to bond, bond formation. And the general formula is this: CO we represent as ketone. We can write this like this also, okay? So don't get confused. And this ketone, always we write this functional group at the center, not at the corners, just like in the other cases like alcohol, or in the cases of carboxylic acid, or in the case of aldehyde, we always write at the corners, right? But in this case, we write in the case of ketone at the center. So remember this. See students, what I have done to represent these, N, we can see N or N dash, you can say. This could 1 2 3, it can be 1 2 3, it can be 1, in case of alkane you have seen, right? So after putting the value of N, whether you put 1 or 2 or 3, same way here you will get the formula, entire formula. And then the functional group, as I have told you, it's ketone. I have already shown you here also. And suffix is on. Let's say for example alkane, we're writing some alkane, and I'm cutting this E portion, and after this E portion I'll remove this E portion, and what I will add? On. It's not all, it's on, O-N-E. Okay, so we will not pronounce it as one, we will pronounce it as on, and it will become alkanon. See students, I am giving you an example of propanol. Just like see here, the same R group, in the place of R we will place the alkane groups, okay, alkyl groups you can say, CH3, CH3. We can write this like this, it's propanol. How many carbon atoms are there? 1 2 3, so means propane. So propane, I'll cut this E and I'll add that suffix on, and it will become propanol. Same way you can write butanon, okay? Now see students, here I'm talking about butanon. So here in the R, at the place of R, we have placed this and we have placed this. How many carbon atoms we require? 1 2 3, right? And 4 is already here with the ketone group. So that's why you don't have to write, for butanon you don't have to write 4 carbon atoms, because already 1 carbon is with the ketone group. So including this we have 1 2 3 4. So we have adjusted at the center. I told you that we have to adjust at the center. So the branch, so the chain start from here. So we can count here 1 2 3 4. I told you in the last class that whenever the branch or whatever the ring or whatever the functional group starts, so you have to count from the nearest side, okay? You can count from here also, but if you count from here, this place will take at the third place, which will be a wrong one if you'll do it. So you have to do it from the nearest side. So 1, 2, 3, 4. So see what I have written: butane 2. So students, see, I have written butanon. So how many carbon atoms we have in butanon? 4 carbon atoms. 1, 2, 3, 4. We will not mention one more of the alkyl group and will not represent over here, because why? Obviously there is one carbon is already there in the ketone group, right? So we will not count another one carbon here, arranging it and making the name of the compound wrong. So see, one carbon is already there in the ketone, so this ketone group will represent this. So at which place ketone group is there? From this place. We will count from the nearest side, right? If you count from here, this ketone group will take place at the third position, but if you count from here, it will take in the second position. So we will count from here. So what we have count? Butane 2 on. Butane 2 on. You can write 2 butanon also. If I have to write down pentanon, okay, how will you write pentanon? CH3, CH3, CH2, let's say, and we have to place the ketone group always at the center. So how many carbon atoms are there? 1, 2, 3, 4, 5. Great. 5 carbon atoms we have, right? But here I have done something wrong. What? We have to mention over here 2, because there will be, if I will be increasing like this, if you make the branch of it, then if you make a chain structure of it, you will get to know what mistake it is, right? So this one will be pent 2 on. You can write 2 pentanon. Clear? This is the way how you have to write, how to give them a name.